Damn. I know, it feels like this massive hurdle, but what if I told you there's a much smarter way to conquer it? We're not just going to study harder, we're going to study smarter. Let's build that game plan right now.
Look, if you're staring at chapters on solutions, electrochemistry, and chemical kinetics, and just feeling that pressure build, trust me, you are not alone. It's a huge syllabus, I get it. But what if there was a way to cut through all that noise?
So you've probably been handed a document like this, right? A massive question bank. And at first glance, it looks like just another mountain to climb. But it's not. This is your secret weapon. It literally contains the DNA of the exam itself. And today, we're going to learn how to decode it. And here's the absolute core idea, the thing I really want you to take away. Success isn't about trying to memorize every single page of your textbook. No way. It's about recognizing the patterns. Year after year, the exam asks the same few types of questions. They just wear a different disguise. Our job is to see right through it. So here's our roadmap for today. We'll start by talking about the challenge itself. Then we'll break down the 3 fundamental question patterns: the math problems, those conceptual why questions, and the case studies. And finally, we'll wrap it all up into a super simple strategic study plan you can start using like today.
First up, pattern 1, master the math. Okay, this is where we tackle all those numerical problems, the calculations that can seem a little intimidating, but are actually your fastest path to scoring some really big marks.
You see, a lot of these problems are designed to look complicated. They'll give you a whole scenario, a bunch of different values, but at their core, they're really just asking 2 things. Do you know the right formula? And can you plug in the numbers correctly? That's it. It's a puzzle, and every puzzle has a clear solution.
So let's just walk through a classic one, calculating the dissociation constant for acetic acid. First things first, you scan the problem and pull out the key data they've given you. In this case, it's concentration and conductivity. Step 2, you grab the right formulas from your toolkit. Now, this is a multi-step process, right? You'll need one for molar conductivity, another for the degree of dissociation, and then the final one for the constant itself. And the last step? That's the easy part. Just carefully substitute the values and solve. And this is exactly what that process looks like on paper. Just notice how each step has its own specific formula. These aren't just random equations you have to memorize. They're a literal roadmap, guiding you from the question straight to the answer. Your only job is to know the map.
So, where should you focus your practice time? Here's your hit list. If you can get really confident with problems using the Nernst equation, Faraday's laws, basic molarity and molality, Kohlrausch's law, and half-life calculations, you've basically got pattern 1 covered.
All right, with the math covered, let's shift gears to our second pattern. This is where we put the calculator away and really dive into the core concepts. I like to call this one, explain the why.
I guarantee you've seen a question like this. It's not asking for a number, it's asking for a reason. Why do fish and other aquatic life prefer cold water? The answer isn't a calculation, it's a fundamental principle of chemistry. And the answer is a concept you definitely already know: Henry's law. Cold water can simply hold more dissolved oxygen. Why? Because as the law states, the solubility of a gas goes down as the temperature goes up. More oxygen means happier fish. It's a simple, elegant answer that's all about the concept. Another classic why question is all about comparisons. For example, what's the real difference between a primary battery, like the one in a TV remote, and a secondary battery, like the one in your phone? Well, it all boils down to one simple thing. Can the chemical reaction be reversed? One is a one-way street, you use it and it's done. The other is rechargeable.
And hey, don't forget about graphs. This might look complicated, but it's a super common why question in disguise. You'll be asked to explain these deviations from Rolt's law. Just look at the graph. That dotted line shows the ideal perfect behavior. The curve that humps up, that's a positive deviation, meaning the molecules are kind of pushing each other away. The one that dips down, a negative deviation. They're attracted to each other. The whole answer is right there in the shape of the curve. Being able to read these visuals is key.
Okay, time for our third and final pattern, crack the case. This is where the examiners really test if you can take all that math and all those concepts and apply them to a practical, real-world situation. So let's meet Arav Sharma. He's got a great recipe from his grandmother and a big idea. He wants to launch a healthy, fizzy fruit drink. Now, this isn't just a random story. It's a multi-part chemistry problem waiting to be solved.
So the first question is pretty straightforward. He wants fizz. How does he get it? What does he need to add to that fruit drink to make it all bubbly and carbonated?
And the answer, of course, is the most famous fizz maker on the planet, carbon dioxide. All Arav has to do is dissolve CO2 gas into his drink to get the carbonation he's looking for. Simple. Part 1 of the case cracked. But now the questions get a little more advanced. Which scientific law is actually at play here? And, thinking practically, what does he need to be careful about when he's bottling the drink to make sure it stays fizzy? And here's the complete solution. It's Henry's law again. That's the key. It tells him that to get more CO2 to dissolve, he needs to crank up the pressure. And that idea directly leads to the precautions. He has to seal the bottles under high pressure, and he has to make sure the caps are perfect to keep that pressure locked in. See? One core concept solves the entire case study. So there you have it. We've broken down the 3 main patterns you'll see on the exam. Now let's put it all together into a simple, really powerful study plan that takes you from feeling overwhelmed to feeling totally empowered. Here it is, your 3-step approach for every single question you face. The second you read a problem, your first thought should be identify the pattern. Is this a math problem, a why question, or case study? Step 2, you recall the core concept or formula that goes with that pattern. And finally, step 3, you apply the method and solve it. Identify, recall, apply. That's the entire game.
I really want you to shift your mindset with this. You're not just passively answering questions from a textbook anymore. You're actively decoding them. You're solving puzzles. And honestly, that is a much more powerful and way more fun way to tackle your revision. So, my final question for you is this. What's the